Because I take it over a long enough time period and I say, you know, I'm going to have 1 million people visit the website, you know, over the course of the day. If it's, you know, if it's the Yahoo homepage, I'm going to pick one of those people, right? So I've averaged out over the different time periods of the day. Maybe certain people have to go online only at their lunch break, and other people go online, you know, during the day because they don't have a job. And these are going to be different sets, but so I somehow need to deal with this. There are definitely some issues there to make sure it's a random sample. So you do need to worry about those cases. Yeah.
If you know that you have a varying distribution there, isn't that a lot different from the coupon collection problem where it's more like a uniform distribution, and so you have the same probability for each chunk, whereas here it seems like you need a PDF to actually figure that out.
Yeah, so this mapping is a little, is not completely obvious to see. Yes, that's a good point. It turns out it's basically the same analysis then. So this is kind of an example of a very similar phenomenon with the similar analysis. You get this extra log term. If you say I want 1 in every 5% bin, you can't just do 20 people. You need this extra log factor for this to work. So it's not a direct application of this analysis, but kind of how it works is what you're going to say is I'm going to divide up the space into these 20 bins. And I know that each bin has 5% of all the customers. Okay? And now I get a random person, they're going to fall in one of those bins with each of those bins with equal probability. So that's kind of how you map it. This is the way I described as a little bit stronger property, so it's a little bit hard to see. But it takes some thought how to map one problem into another, and we'll see different examples of kind of this same phenomenon. You need to hit every bucket. You want to get an example in every bin. These are kind of the same thing. I'll try and kind of bring this up in other examples throughout the semester where we see something like this happen. This will have an extra log factor. To have the collisions, you're going to need about square root n or square root 2n. Those are kind of the two main takeaways from this lecture. And then we'll see this third phenomena on Wednesday. Okay, so I'll try and get the first. I know the add drop deadline is really early, is Wednesday, like it is every year. I'll see if I can get the first homework assignment up by Wednesday, just so you can see what it's like. I might not be able to. I want to kind of tweak some things first. If you're curious, you can look off my webpage. I linked to the class from last year, and it won't be too different from that. So if you're concerned about that, you know, go on there and see if it seems feasible. All right.